What's going on, guys? Today we're going to be discussing the average normal stress in an axially loaded bar. So for an axially loaded bar question, we assume that the material is homogeneous, so it has the same physical and mechanical properties within its volume, and that the material is isotropic, so that it has the same properties in every direction. A bar is defined as a long and slender member with a constant cross-sectional area, and the weight is negligible while the external force is applied through the centroid axis of the sectioned area. The average normal stress is defined as the force over the area, the cross-sectional area. We'll do a quick example to demonstrate the calculations done in an axially loaded bar question. So right here, the bar in the figure shown has a constant width of 35 millimeters and a thickness of 10 millimeters. So it has a cross-sectional area as such. So we have to take, since there are multiple forces acting on the beam or the bar at different positions, we have to take multiple sections. So we'll take one section cut right here, and then we'll take one section cut right here, and one last section cut right here. We take the sections after or before there is a new force introduced. So in the first section cut, starting from the left, there is a 12 kilonewton force to the left, and the resulting normal force will be 12 kilonewtons to the right. In the second section, there is a 12 kilonewton force to the left and two 9 kilonewton forces to the left. That makes a normal force of 30 kilonewtons to the right. And finally, in the third section, a summation of 22 kilonewtons to the right for the normal force. So the max force involves the largest normal force, NBC, divided by the cross-sectional area. So the max normal force is 30 kilonewtons divided by 0.035 meters times 0.010 meters, which gives us a total of 85.7 megapascals.